Hey guys, so in this video I will be covering trigonometry for TS EAMCET September 10, 2020 shift 1. So I've been meaning to do a video for some time now, but I got my COVID jab and I was down with fever. So anyway, let's start with the first problem. So this one is sine raised to the power 4 pi by 8 plus cos 4 3 pi by 8 plus minus sine raised to power 4 3 pi by 8 plus sine 4 cos 4 sine 4 again. So pi by 8 we know is what 180 by 8 is 45 by 2. So we don't really have formulas, standard formulas for 45 by 2 degrees. Although we do have for 45 degrees, 30 degrees, 60 and 90. So first I will try to see if we can get rid of this 8 and make it pi by 4 if possible. Secondly, these are all degree 4 terms. When I am trying to solve these problems, I try to see if the power may be reduced. So let us try to do that. First let us consider cos raised to the power 4 7 pi by 8 minus sine 4 7 pi by 8. So this is cos 4 minus sine 4. So a square minus b square is a minus b into a plus b. Similarly, a4 minus b4 could be what? A square minus b square into a square plus b square. Just replacing a in this term by a square and b by b square. So this one could be written like this. Why am I doing this? Because this is 1, right? Cos square theta plus sine square theta is 1, so this is 1, and product of 1 with anything is just that. So now this is what? Cos square theta minus sine square theta, which is what? Cos 2 theta. Cos 7 pi by 4. Similarly, as I have done for this term, I can do it for this term as well. This is just what? Cos of 2 into 3 pi by 8, which is equals to cos 3 pi by 4. Now these 4 terms just become this, cos 7 pi by 4, which is cos pi minus pi by 4 plus cos 2 pi minus pi by 4. Cos pi minus theta is what? Minus cos theta. Cos 2 pi minus theta is cos theta. Oh, this is 0. So we can just remove these 4 terms. Now the problem is just this. Sine 4 pi by 8 plus sine 4 5 pi by 8. This is a square plus b square, like a4 plus b4, right? I can easily write this as this. Minus 2a square b square, right? If you open this, this will become a4 plus b4 plus 2a square b square. So these two will get cancelled and you will be left with this. So I am going to do that. Now I will also write this as which is equal to what? Minus cos pi by 8. But if there is a square over here, so this will become what? Cos square pi by 8. Now it's clear why I am doing that, because the bracket will reduce to this, a square cos square theta plus sine square theta, which is what? Which is 1. So this is 1. 1 square is 1. and this is 2 sine square theta cos square theta. So if I take half over here, I will be left with 4 sine square theta cos square theta, which is what? Sine 2 theta whole square. So this is 1 minus half into sine pi by 4, sine square pi by 4. Sine pi by 4 is root 2. So square of 1 by root 2 is half. So 1 minus 1 by 4 is equals to 3 by 4. So there are n number of ways to solve this problem. It's not that tough. We did it this way. Now let us look at the next problem. If you look at this problem, this is such a huge equation, like some people might get scared by just looking at this, right? Like, what the hell is going on here? There's a cosecant inverse, there is tan square, then there is cos, then there is cot, then there is secant, and there is alpha and pi, and a whole lot of things happening in numerator and denominator. Honestly, it is scary. So let us try to do it one term at a time, and then you will realize this problem is not that difficult. So alpha by 4 minus pi by 4. Why do I do that? Because I know the formula for tan A minus B is tan A minus tan B divided by 1 plus tan A tan B. Tan pi by 4 is 1, so this is what? Tan alpha by 4 minus 1 by tan alpha by 4 plus 1. Right? So what is tan square alpha minus 4 pi by 4? Square of this? Is equals to a square plus b square minus 2ab divided by a square plus b square plus 2ab. Now we have tan square alpha minus pi by 4 minus 1 and plus 1. Both of these things are here. So this minus 1 and this plus 1. Minus 1 and this whole thing plus 1 is also there. So when you take the LCM, these two will get cancelled out and you will be left with this. The minus sign over here, so minus tan square alpha by 4 minus 1 minus 2 tan alpha by 4 and plus over here, so tan square alpha by 4 plus 1 minus 2 tan alpha by 4 plus tan square alpha by 4 plus 1 plus 2 tan alpha by 4. This is cancelled with this, and this will be cancelled. So this whole thing is equal to minus 4 tangent of alpha by 4 by twice of 1 plus tangent square alpha by 4. Now 1 plus tan square theta is sine square theta, which is equals to cos square theta if this is in denominator. So this is 1 by secant square theta, so cos square alpha by 4. Now minus sine as well. So tangent is what? Sine alpha by 4 by cos alpha by 4. So this will be cancelled. So minus 2 sine alpha by 4 cos alpha by 4. So minus sine alpha by 2. So this whole thing is just sine alpha by 2 with a negative sign. minus sine alpha by 2. Now I have to add cos alpha by 2 and cot 5 phi, and then there is a secant 11 alpha by 2. So the expression is minus sine alpha by 2 plus cot alpha by 2 into cot 5 alpha, cos alpha by 2, sorry, cos alpha by 2 into cot 5 alpha, and this is multiplied with what? Secant 11 alpha by 2, and this whole is cosecant inverse. I've already solved the one big problem. Now the second smaller problem is this. Minus sine alpha by 2 plus cos alpha by 2 into cot 5 alpha. Cot can be written as cos by sine, right? Now take sine 5 alpha as the LCM. You will get minus sine alpha by 2 into sine 5 alpha plus cos alpha by 2 cos 5 alpha. So cos A cos B minus sin A sin B. What is that? It is nothing but cos of A plus B. Cos of, this is not there. Cos of A plus B, cos of 11 alpha by 2. And 1 by sin 5 alpha is what? Cosecant 5 alpha. Right? So this whole thing is nothing but cos 11 alpha by 2 into cosecant 5 alpha. Now this will be multiplied with secant 11 alpha by 2. So this is 1. So I'm left with nothing but cosecant inverse of cosecant 5 alpha in the end, which is just 5 alpha. So the problem was big, but it solves on its own step by step. Okay, next problem. If A is 15 degree, B is 17 degree, C is 13 degree, then can you say cot of 2A plus cot of 2B plus cot of 2C is equals to cot 2A, cot 2B, cot 2C. Reason given is in a triangle PQR, tangent P by 2, tangent Q by 2 plus tangent Q by 2, tangent R by 2 plus tangent R by 2, tangent P by 2 is 1. So first I want to see if R is correct, whether this expression is indeed true. In a triangle PQR, so P plus Q plus R is pi. Now we want to see whether R is correct or not. So this is correct or not is first what we want to see. Whether this is equal to 1 or not. So how to approach it? First, let us just assume R is pi minus P plus Q. I will have to do that over here as well. So if I take R by 2 common, I will be left with tangent Q by 2 plus tangent P by 2 into this. So which is equal to tan P by 2 tan Q by 2 plus tan P by 2 plus tan Q by 2. Tan pi by 2 minus P plus Q by 2 is what? Cot P by 2 plus Q by 2. Now cot is 1 upon 10, so this will be written like this. And we know what is the tangent of A plus B. is equals to tan A plus tan B tan A plus tan B by 1 minus tangent A tangent B. Now this whole thing is in denominator, so when I take it into the numerator, we will have to take reciprocal of the whole thing. So it's easy to see that this will be cancelled and you will be left with this plus this. So this will be cancelled with this. In the end, you will be left with 1. So R is correct. In a triangle PQR, this holds. So R is true. R is true. So this option is not there. Now I want to see if R is true, then whether this will hold or not. If A is 15, B is 17, C is 13, then A plus B plus C is 45. So 4A plus 4B plus 4C is 180 degree or pi. Now similarly in triangle PQR, if P plus Q plus R was pi, then we saw that tan P by 2 plus into tan Q by 2 plus this was equal to 1. Similarly, if 4A plus 4B plus 4C is equals to pi by 2, so tangent 4A by 2, tangent 4B by 2 plus tangent 4B by 2, tangent 4C by 2 plus tangent 4C by 2, tangent 4A by 2 should be equal to 1. I am using R, right? R is correct. So I am using R to see if A holds or not. Now this will be 2, this will be 2, again 2, 2, 2, 2. So if I use R, I should get this tan 2A tan 2B plus tan 2B tan 2C plus tan 2C tan 2A is equal to 1. Now we want to see whether this can lead to this, right? Yes, it can. Just divide this whole thing by tan A, tan B, tan C, tan 2A, tan 2B, tan 2C, sorry. If I divide this by tan 2A, tan 2B, tan 2C, tan 2A, tan 2B, tan 2C, tan 2A, tan 2B, tan 2C is equals to 1 by this. So cot 2A, cot 2B, cot 2C. So this is cancelled. This is cancelled. These are cancelled. So 1 by tan is cot. So cot 2C plus cot 2A plus cot 2B is equals to cot 2A, cot 2B, cot 2C. So yes, so R is the correct explanation of A. That's it. The solution set of this equation, tan theta plus 5 cot theta is equal to secant theta. As we have already seen, converting cos and tan and cot into sine and cos is very helpful, right? So let us do that. Let us try to make our lives easier. Sorry, cos theta. So this will be what, sine square theta plus 5 cos square theta by sine theta. Cos theta is 1 by cos theta. So sine square theta plus 5 cos square theta can be written as 1 minus sine is equals to sine theta. I have converted cos square to sine and not sine to cos because the power 1 term is sine theta. So sine square theta plus 5 minus 5 sine square theta minus sine theta is equal to 0, or minus 4 sine square theta minus sine theta plus 5 is equals to 0, or 4 sine square theta plus sine theta minus 5 is equal to 0. Now let us just try to factorize it. 4 times 5 is 20, so 5 sine square theta, 5 sine theta minus 4 sine theta minus 5. So take sine theta common, 4 sine theta plus 5, minus 1 common from here, 4 sine theta plus 5 is equal to 0, or sine theta minus 1 into 4 sine theta plus 5 is equal to 0. Sine theta is equals to 1 and sine theta is minus 5 by 4. Minus 5 by 4 is minus 1.25. As we know that sine lies between minus 1 and 1, so this solution does not exist. Sine theta is 1, okay? So theta is 90 degree. But does tangent exist at 90 degree? No, so none of the solutions really lead to anything, and this is just an empty set. Okay, next problem. Tangent inverse of 1 by 5 plus half of secant inverse of x plus tangent inverse of 1 by 8 is equal to pi by 8. So first I will combine these two. What is tangent inverse of a plus tangent inverse of b? The formula. Let us assume that this is y. So tan y is equals to tan of a plus b. Tan of a plus b is tan a plus tan b by 1 minus tan a tan b. So y is equals to what? Tangent inverse of a plus b by 1 minus ab. So tangent inverse of a plus tangent inverse of b is equals to this. So tangent inverse of 1 by 5 plus tangent inverse of 1 by 8, right? We can solve it. 1 by 5 plus 1 by 8 minus 1 by 5 into 1 by 8 is equals to what? Tangent inverse of LCM. So 8 plus 5 by 40 to 1 upon 1 minus 1 by 40. So 40 minus 1 divided by 40 will become 40 over here. So tangent inverse of 13 by 39, so 1 by 3. So tangent inverse of 1 by 3. So the equation is reduced to half of secant inverse of x plus tangent inverse of 1 by 3 is pi by 8. Let us take this thing over here. Half of secant inverse of x is pi by 8 minus tangent inverse of 1 by 3. If I remove the half, this will become this and this. Now as I had seen, tangent inverse of a plus b is equals to tangent inverse of a plus b minus 1 by ab. If b is equals to a, this will become 2 tangent inverse of a, which is equals to tangent inverse of 2a y 1 minus a square. So subsequently, this will become tangent inverse of 2a by 1 minus a square, that is 1 by 3 square. So secant inverse of x is pi by 4 minus tangent inverse of 2 by 3 by 1 minus 1 by 9, which is equals to pi by 4 minus tangent inverse of 2 by 3 into 9 by 9 minus 1 is 8. So this is pi by 4 minus tangent inverse of 3 by 4. Again, pi by 4 is what? Tangent inverse of 1. So we will use the formula again of tangent inverse of a minus tangent inverse of b is equals to, if I put minus b instead of b, so this will become tangent inverse of a minus tangent inverse of b. is tangent inverse of a minus b by 1 plus ab. 1 minus 3 by 4 plus 1 plus 1 into 3 by 4. 1 by 4 divided by 7 by 4 is tangent inverse of 1 by 7, which is secant inverse of x. Now x equals to secant of tangent inverse of 1 by 7. If I take square, x equals to this. Now we all know that secant square theta is 1 plus tan square theta. So this will be this. Tangent inverse of tan of tangent inverse. So this, and square is already there. So 1 plus 1 by 49 is 50 by 49. So x square is this. 50 by 49. Okay, next problem. Assertion cosecant hyperbolic inverse of 3 is log of 1 plus root 10 by 3. Reason this is a root of this equation, blah blah blah. Let us try to solve this equation. Xp square minus 2p minus x equal to 0. So p is equals to minus b. So 2 plus minus square root of b square. So minus 2 square minus 4ac is 1 and c is minus x divided by 2a. So 2x is equals to 2 plus minus 4 plus 4x by 2x. Square root of 4 is 2, so 2 and 2 all get divided and cancelled. So 1 plus x by x, which is equals to e to the power cosecant hyperbolic inverse of x, or cosecant hyperbolic inverse of x is equals to natural log of 1 plus minus square root of 1 plus x by x. So plus sign when x is greater than 0 and minus sign when x is less than 0. This is implied from R, right? This is from R. And we already know that cosecant hyperbolic inverse is defined by this. So R is correct. R is correct. So if R is correct, then what will be cosecant hyperbolic inverse of 3? So 3 is greater than 0, so I will be using plus sign. 1 plus, wait a minute, x into x is x square. One mistake. 1 plus 3 square by 3 is ln 1 plus root 10 by 3. Ln and log are same because it is assumed that this is log with the base e. So this option is correct. In a triangle ABC, if angle A is equals to 3 times angle B, CA is 9 and BC 16, then the length of AB is what? Now when I was solving this problem, I thought this was a lengthy problem compared to the others. Took a lot of time to solve ABC. So if this angle is x, this angle is 3x, and AC is 9, BC is 16, what is this? We have to find out. First I want to draw a perpendicular, so this is P. So P is equals to what? 9 sine 3x, and P is also equal to 16 sine x. So I want to solve this equation first. Okay, so sine a plus b, very lengthy problem. Sine a cos b plus cos a sine b. Instead, if we remember the formula, it becomes much easy. Sine to theta is 2 sine theta cos theta. Sine a cos b plus cos a sine b, sorry. Cos to theta is cos square theta minus, 'minus' 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 So I will cancel sin x. Sin x is equals to 0 is not a solution because that would mean x equal to 0. So this will not be a triangle. So I'm not considering this. So 18 cos square x, or I can write this as 2 cos square x minus 1 instead of uh, cos square x minus sin square x. I can write this as 2 cos square x minus 1. So 9 into 2 would be 18 cos square x minus 9 is equals to 16. So 36 cos square x is 25, or cos x is 25 by 36, square root is 5 by 6. Okay. So this can be used to find out the value of this length, just 16 cos x, but this will still remain because we don't know cos of 3x. I know cos of x, so can I find out cos of 3x? Cos 3 is cos 2 plus 1 is cos a cos b minus sin a sin b is equals to 2 cos square x minus 1 into cos x minus 2 sin square x cos x. Take cos x common. 2 cos square x minus 1 minus 2 sin square x is 1 minus cos square x is equals to cos x into 2 plus 2 is 4. Cos square x 1 and 2 is 3. Now cos x is given to me. I can find out cos 3x. Four into 25 by 36 minus 3. 25 times 4 is 100. So 100 by 36 minus 3. Okay, 100 minus 36 times 3 is 108 by 36. 5 by 6 into minus 8 by 36, which is what? 4 times 2 is 8, 4 times 9, 3, minus 5 by 27 is cos 3x. So I can find out the value of AB as, this is 9 cos 3x, this much length, and this much is 16 cos x. 9 cos 3x plus 16 cos x. 9 cos 3x plus 16 cos x. Cos 3x is minus 5 by 27, and cos x was what? 5 by 6, right? 5 by 6. So 1 by 3 and 8 and 3. 40 by 3 minus 5 by 3 is 35 by 3. 35 by 3. Next problem. In a triangle ABC, 1 plus cos C by R1 plus R2 plus 1 plus cos A by R2 plus R3 plus 1 plus cos B by R1 plus R3 is what? Blah 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 blah. I will first look at this R1 plus R2. We know the formula for cosine is a square plus b square minus c square by 2ab. R1 is delta by s minus a. R2 is delta by s minus b. Delta is area of triangle, s is semi-perimeter. To take the LCM, a square plus b square plus 2ab minus c square by 2ab, 1 by, take delta common, 1 by s minus a plus 1 by s minus b will be this, s minus b plus s minus a by s minus a into s minus b. A square plus b square plus 2ab can be written as a plus b whole square. 2ab and 1 by delta, and s minus a into s minus b will go in the numerator. 2s minus a minus b, 2s minus a minus b. This is a square minus b square. I'm talking about the formula. In actuality is a plus b whole square minus c square. So a plus b plus c into a plus b minus c. This can be written in that way. And this is s minus a and s minus b. Delta 2ab. 2s is a plus b plus c. So a and b will be cancelled. So c. A plus b plus c is 2s. A plus b minus c can be written as a plus b minus c can be written as a plus b plus c minus c minus c. A plus b plus c is 2s minus 2c. So you can write it as 2s minus 2c, and you already have s minus a, s minus b by delta, 2 delta in fact, abc. Now let us take the 2's out. S into s minus a into s minus b into s minus c, and 2 here, so 2 into 2 by 2 into delta abc. Now s into s minus a into s minus b into s minus c is delta square, because we know that area of triangle is given by this, right? So this is delta square, and 2 and 2 are cancelled, so 2 into delta square by delta abc. Delta cancelled, 2 delta by abc. Now because of symmetry, this term will also be 2 delta by abc, and this will be also 2 delta by abc. We don't need to waste our time. If you want to check, you can check, but this will be the same. So end result is 6 delta by abc when you add this term 3 times. Now we know that capital R is abc by 4 delta. This implies that delta by abc is 1 by 4r. So it's very important in this exam that you remember the formula for R1, R2, R3, R in radius. Otherwise you will not be able to solve these problems. So this is 3 by 2R. Let's look at the last problem on trigonometry. If in a triangle ABC, if cos A, cos B plus sin A, sin B, sin C is 1. So I thought this was a very tricky problem. Since we know that sin C is less than equal to 1, right? So this whole thing, sin A, sin B, sin C will be less than equal to sin A, sin B, right? So this thing, cos A, cos B plus sin A, sin B, sin C will be less than equal to cos A, cos B plus sin A, sin B. Now this thing is given to us as 1, and this will be what? Cos of A minus B. So cos of A minus B is greater than equal to 1. This has only one solution, which is cos of A minus B is 1, because this value is never greater than 1. So this is possible only in the case A minus B is equals to 0 or A is equals to B, and this happens when sin C is equal to 1. Sin C is 1, then C is equals to 90 degrees. A and B are equal, C is 90, so A and B are both what? 45 degrees. Now we know that A by sin A is equals to B by sin B is equals to C by sin C in a triangle. So A by sin 45 is 1 by root 2. 1 by root 2 sin 90 is 1. So A is to B is to C is 1 by root 2 is to 1 by root 2 is to 1 is equals to 1 is to 1 is to root 2. 1 is to 1 is to root 2. I thought this was tricky because if you do not start with this, you will not be able to solve this problem. Okay, so we are done with trigonometry, and we will either do functions, or maybe we will start with calculus in the next video. Okay, thank you everyone.